lesson from College Algebra 2.1 is a review of equations of lines. And the coordinates where this crosses the y-axis is also known as the y-intercept. Now, since these are all written in slope-intercept form, if I can identify the b value, I will know the y-axis, or the coordinates of that point. In this case, the b is 4. Now, since they want the coordinates, remember y-intercept has an x value of 0 and a b value of 4. This is a vertical line through x equals, oops, it's not quite vertical, but you get the idea, -3. Notice a vertical line through x equals -3 is never going to intersect the y-axis, so there is no y-intercept. In this question, there's an invisible +0 off to the side, so my y-intercept is at the point 0, 0. And then this is written a little backwards. If it makes you feel better to write it like that, that's fine. The y-intercept is at 2, so his coordinates are the point 0, 2. When I'm given an equation of a line, if I can identify my slope and my y-intercept, I can give you the entire equation. So slope I like to count, so I'm going to go from here. It's a little hard to tell sometimes when they don't give you points, so we'll go from here to here. This goes up 1, 2, 3, 4 over 2. So a slope of up 4 over 2 to the right reduces to a slope of 2. And then the y-intercept is at the point 0, 4, or I'll just call it 4. And then substituting in those values, and for m and b, I get 2x plus 4. Same idea here. It would be better if they told me which points were actual intersection points, but we'll just assume those are them. So I notice I'm going to travel up 1, 2, and then left 1, 2, 3, 4. So for my slope, if I travel up 2, but then left 4, that is a slope of -1/2, and my y-intercept is a -2. So substituting in those values, I'm going to get -1/2 x minus 2 y equals. Alright, moving along. This time they give me some interesting clues. First, we have a slope of 2, so there's my m, and a y-intercept of 4. Whoops, that's a b, excuse me. So y equals 2x plus 4, and they want the answer in slope-intercept form. So be careful, sometimes the directions will want it in standard form or point-slope form. We got to be careful about that. This particular problem, they give you a point, but it's a very special point. Since the x is 0, that tells me that -4 is my b value, and my slope is 2. So going back to my general slope-intercept form, I have 2x minus 4. Now the next question is not so easy. They give you a point and they give you a slope, and this is not a special point to me. So we're going to use what's called point-slope form, which is y minus the y coordinate equals slope, and then x minus the x coordinate. So here's my x coordinate, here's my y coordinate, and here's my slope. So y minus the y coordinate of 6 equals slope 1/2, and then x minus the x coordinate of 2. Now they wanted our answer in slope-intercept form, so I'm going to distribute the 1/2, and then add 6 to both sides, so the y is isolated, and I get 1/2 x plus 5. Same idea here. 3 and 1 is the point, so y minus the y coordinate equals slope. I'm going to rewrite it as a fraction, because I deal with fractions better in my head, and then x minus the x coordinate. So distributing the 1, or the 3/2, excuse me, y minus 1 equals 3/2 x, and that'll be a minus 9/2. Now if I add 1 to both sides, adding 1 is like adding a 2/2. So that would be a 3/2 x minus 7/2. X-intercept of 2 and a y-intercept of 5. Now the y-intercept is very interesting to me, but the x-intercept, since he's an intercept on the x-axis, that would be the ordered pair 2, 0, and a y-intercept of 0, 5. Now he's going to be exciting in a minute because I'm going to use that as the b value. But first I need to calculate slope. So slope between 2 points is the difference in the y values over the difference in the x values. Make sure you go in the same direction. So I'm going to go 5 minus 0 over 0 minus 2, and I'm going to get a slope of -5/2. And my y-intercept is a 5, so substituting those values into slope-intercept form, I get -5/2 x plus 5. And then, next question, very similar. X-intercept would be the ordered pair -3, 0, and a y-intercept would be the ordered pair 0, -1. So I'm going to use him as the b value in just a minute, but right now I need to find my slope. So -1 minus 0 over 0 minus a -3. So that ends up as -1 over +3, which is a -1/3. So finally, we're going to substitute in the values, negative 1/3 x and then minus 1. Okay. This time they want the answer in standard form. Standard form looks like this: ax plus by equals c. And the idea is you can't have any fractions or decimals, and the a must be a number that's positive. So if it's not in those, falling into those categories, you got to do a little rearranging. 2 points, I don't have slope, so I need to calculate slope first. y2 minus y1 over x2 minus x1 simplifies to negative 2 over negative 1, which is a positive 2. Now you could use either one of these points for point slope form. I'm going to choose this point. So y minus 6 equals 2, x minus 2. And then standard form is a little weird. I basically want to keep the a value positive. The a is the coefficient of my x. So I'm going to rearrange a little bit backwards. I'm going to subtract the y and then add the 4 over, and then I'm going to flip it around totally. So it's going to be 2x. If I subtracted the y over, it'd be a minus y. If I added the 4 over, that'd be equal to a negative 2. That is standard form for that equation. Good news, kind of. This ordered pair is a y-intercept. Unfortunately, since I want standard form, I don't think I really care about slope-intercept form anymore. But I do need to calculate slope. So 3 minus a negative 6 over negative 3 minus 0 would be 9 over negative 3, also known as negative 3. Now I am going to use this point for my point slope form because it's going to give me less math. Y minus a negative 6 is y plus 6, and then negative 3 slope times x minus 0. If I distribute the negative 3, that's just going to be a negative 3x, and since I want the x to be a positive coefficient, I'm going to go ahead and add that over. So I'll get 3x, and then there's still a plus y, and then I would have had to move the constant over by subtracting 6. I do that little rearranging quite fast, mostly in my head for this level of class. If you find that you are very error prone when you don't write it out all the steps, please do write out more steps. Okay, this next clue, giving me a point, that's good, and then they say that I'm parallel to this line. Well, if I'm parallel to this line, that means I have the same slope. So first thing I need to do is calculate what his slope is. Well, slope-intercept form would be helpful. I would add the 3 and then divide by 7. So his slope would be a 3 over 7, and since I'm parallel to him, I have the same slope. So y minus the y-coordinate would be y plus 4 times 3/7, and then x minus the x-coordinate would be x plus 2. Now remember, I'm supposed to do standard form here. You have a couple options. You can get rid of the fraction right this very second, or you could distribute and then get rid of the fraction. I'm going to go ahead and distribute right now, and then I'll worry about getting rid of the fractions. If it became excessively icky distributing this fraction, I would have gotten rid of it in the first step. I'll show you on one of those later on. So this is a 6/7. Now to get rid of my fractions, I would have to multiply everything by a common multiple of, well, 7 in this case. So 7y plus 28 equals 3x plus 6. Now remember, I want to group the x and y together, making sure the x stays positive. So I'm going to subtract the y over here, and I'm going to subtract the 6 over here, and then I'm going to pick it up and turn it around. So I would have 3x, I would have subtracted the 7y, I would have subtracted the 6 over and made it equal a positive 22. This time, if I'm perpendicular, what that means is his slope is a negative 1, but the perpendicular slope would be the opposite reciprocal to negative 1, so opposite would be a positive, and then the reciprocal of 1 is still a 1. So using my point slope form, y plus 2 equals positive 1, and then x plus 1. Kind of boring to distribute a 1, but I'm going to rewrite it without the parentheses, and then since I want standard form, I'm going to bring the y over by the x to keep the x positive, and then rearrange the constants. So I'm going to subtract the 1 over. 2 minus 1 is 1. Okay, this is probably something you very briefly talked about, direct variation in Algebra 1, and you may have never seen inverse or indirect variation. But these are the equations, k times x versus k divided by x. And our first step is to set up the equation. R varies directly as t. So I'm going to be using this style equation. R varies. There's always a constant of variation called k. And then if it varies directly as t, it's just k times t. Now the next step is they give you some points. They say r is 10 when t is 2. Well, if I know r is 10 when t is 2, I could solve for k by dividing by 2 on both sides. K is 5. So now I'm going to go back to this original setup and write my actual equation, which is instead of k times t, I'm going to plug in my known k now. It's 5 times t. So this is my equation. I'm going to hold on to him for a second. Then it says, now find r when t is 9. So these problems have a multitude of steps because you need to set up the original skeleton. You need to substitute in values that they give you as clues. You need to find the constant of variation. Then you got to go back and set up the actual equation with the known constant, and then use that new equation to find a final answer. This time y varies directly as the square of z. So we're going to be multiplying k, but instead of just k times z, it's the square of z. So it's z to the second power. So they give me some values. Y is 8 when z is 6. Now 6 squared is really a 36. So if I divide 36 from both sides, 8 divided by 36, let's see, that'd be 2 over 9. Simplify as clean as you can, please. And then my next step is to go back to my general equation, substitute it in the known k value now, and then y and z will stay as variables for now. That's the equation. Now it says find y when z is 9. So y would be 2/9, and then if z is 9, let's see, that's 81 divided by 9, 18, I believe. Sorry if I'm screwing up in my mental math. Y varies inversely as x. So this time inversely means to take k, and instead of multiplying by the next variable, we're going to be dividing by it. So then we're going to substitute in our clues. Y is 10 when when x is 3. The first set of clues just tells you the relationship between y and x, and that's how we find our constant of variation. So multiplying by 3 on both sides, I get a k value of 30. So my general form with the k substituted in is 30 divided by x. Now it says find y when x is 12. So let's see, divide by 6, 5 over 2. That's a 5, excuse my writing, or 2.5 is the fine answer. R varies inversely as the square of t. So this time, R varies inversely means to divide, but instead of just dividing by t, it's the square of t. So they set up 8 equals k divided by t squared, so 16. Oh geez, I should know this, but I don't. 16 times 8, 128. So I know my constant of variation now. I could substitute that back into the general equation. That's my equation. Now find r when t is 9. So 128 divided by 9 squared would be divided by 81. I am not smart enough right now to do this. So I'm gonna, well that's boring. It's just 128 over 81. Okay. Now they get a little more complicated because they could do joint variation, which means more than one variable is included, and you're going to possibly mix inverse with direct, or multiple directs, or multiple inverses. R varies jointly as m and n squared. So that means when they just say jointly like this, everything is going to be multiplied by the k. So m and then also n squared. Only the n is being squared. So now I'm going to substitute in the clues. And then 6 squared would be a 36. So, let's see, I think that's k is 1, because that is, oh no it's not. Try again. 4 times 36, 144, so that'd be 1/2, right? Yes. So, k is 1/2, excuse me. My new equation is now 1/2 times m times n squared, and if they tell me m is 3 and n is 4, I can find the value of y. 4 squared would be a 16. So let's see, that's a 24, I believe. Yes, these do have quite a bit of work, but it's not hard work, and that's the good news. Now the next question, y varies directly as m, but inversely as the cube of n. So y varies directly as m, looks like this, but then when I go inverse of the cube of n, that means it's dividing by n to the third. So setting up my clues, n to the third power would be 2 to the third power, which is 8. Now I tried to simplify the fraction first. 8 over 8 is just a 1. So that simplifies pretty nice. Whoops, try again. Oh yeah, k is 3. And then my equation is 3 times m over whatever n to the third power is. And then it says find y when n is 36, m is 36 and n is 3. So 3 times 36 divided by 3 to the third power would be a 27. So I think that's a 4. Hope my mental math is working today. The circumference of a circle varies directly as the radius. So circumference varies directly as the radius would be k times r. Now we know a little bit of something about circumference of a circle, so this should be interesting. Circle with radius of 7 is circumference of 43.96. So just making sure we substitute in the values in the appropriate place. Now we know you're supposed to include the number pi when it comes to solving for circumference, but that's the other reason you're seeing decimals here is because they've already incorporated an approximation for pi. So we get k is 6.28. That should seem familiar to you. That is twice as big as pi. So basically what they're telling me is circumference is 6.28 or 2 pi times r, which is exactly what circumference is. What about if the radius changes to 11 though? So we're going to approximate. Oh, and we get approximately 69.08 centimeters. There you go. And then these problems are the same sort of setups. We just have to be really careful how we read. So a body falling from rest, the distance varies directly as the square of the time. So distance varies directly as the square of the time. So it's dropped from 400 feet and then hits the ground in 5 seconds. So the distance it fell was 500. The time was 5 seconds, so 5 seconds squared is 25. And I know I should be able to do that, but I can't right now. Its k is 20. So my new equation is 20 times the time squared. So how far did it fall in just 3 seconds? So 20 times 3 squared, which is 9, which is 180 feet. Okay. And then the illumination produced by a light source varies inversely as the square of the distance from the source. So illumination varies inversely means k divided by the square of the distance. So the illumination 4 feet from a light source is 75 foot candles. So the illumination is 75. The distance is 4, so 4 squared is 16. And then, a little calculation here, that means 1200 is my k. My new equation is illumination is 1200 divided by distance squared. And they want me to find the illumination if I am 8 feet, from the light source. So distance squared would be 64. And we get 18.75 foot candles. I'm not really sure what a foot candle is, but I kind of have an idea. It's the measurement of how bright the light is depending on how far away the distance is. I'm going with that. Alright, that is the end of lesson 2.1.